Let's talk about multiplication and division. The very first concept I want to discuss is the multiplicative identity. This is very similar to the additive identity that we discussed when looking at addition. So what was the additive identity? Well, the idea was any number plus the additive identity should equal that same original number. What then is the additive identity? Well, it would be the number 0, right? So adding 0 to any other number will give you that same number back. Let's see if we can extend this concept to multiplication. All right, so the multiplicative identity would be, for example, if we have the number 8 and we multiply it by the multiplicative identity, we should get the number 8 back out. So what number here satisfies this condition? Well, it would be the number 1. 8 times 1 gives us 8, right? So multiplying by the multiplicative identity will not change the original number. Let's look at another example of this. How about a negative pi times the multiplicative identity would give us negative pi. What number is that going to be? Yeah, it's going to be the number 1. It's always going to be the number 1 because the multiplicative identity is the number 1. Okay, so we can sort of have a general rule for this. We could say that 1 times any number a will just return that same original identical number a back out. Now, I want you to notice one thing here. I wrote 3 different multiplication operations here, but I wrote them each a slightly different way. And it turns out there are 3 ways that we can describe a multiplication, sort of 3 ways we can notate it. So the first way we can do this is we can say a times b, and that is equal to a times b, and that is equal to a times b. Okay, so 3 different ways to write multiplication. You can use the little X here, or we can also use the little dot, or we can just write 2 values close to each other, and that indicates they're going to be multiplied together. So this is the idea of a multiplicative identity, and put briefly, it's the concept that you can multiply any number by the multiplicative identity, and that won't change its original value. Okay, let's move on to the next concept now. Let's talk about reciprocals. It's actually a pretty easy concept. So let's take a number. How about the number 6? I want to get the reciprocal of the number 6. How do I do that? Well, I just write 1 over 6. And that's it. 1 over the original number will be the reciprocal of that original number. So 1 over 6 is the reciprocal of 6. We could try another example. How about negative 4? What's the reciprocal of negative 4? Well, it's just going to be 1 over negative 4. And of course, we could also write this as negative 1 over 4. Okay, so negative 1 over 4 is the reciprocal of negative 4. We can also think of reciprocals another way. We can think of them as flipping over a fraction. Okay, what do I mean by this? Well, we started out with the number 6, but I could think of the number 6 as actually 6 over 1 if I wanted to. And then when I take the reciprocal of 6 over 1, what I'm actually doing is I'm flipping it over. 1 over 6 is 6 over 1 flipped over, right? So flipping over a fraction will give you its reciprocal. And so now we can actually work with fractions like, for example, 2/3. Well, what's the reciprocal of 2/3 going to be? Well, flip it over. It's going to be 3 over 2. Okay, so we can get reciprocals of not just like integers, but we can also get reciprocals of fractions by flipping them. There's another interesting thing that happens here. What happens if you take the original number, let's say 6, and multiply it by its reciprocal? What do we get? We're actually going to get the number 1. The number 1 is the multiplicative identity. So multiplying a number with its reciprocal equals the multiplicative identity. And we can try that with 2/3 as well, right? So 2/3 multiplied by 3/2 if you know your fractions, you'll see that everything here cancels out. And once again, we just get the number 1. Okay, so that's another interesting property of reciprocals, where the original number multiplied by the reciprocal will give you the multiplicative identity. Okay, let's take a look now at division. So division I'm going to think about in a few different ways, because division can be a little bit more difficult than multiplication. The first way is to think about physically taking an object and dividing it into pieces, right? So when I say 1 divided by 4, what do I mean? Well, I kind of mean, let's imagine we have an object and we divide it up into fourths, right? So 1 divided by 4, 1/4, well, that would just be this amount right here. And this would be essentially 0.25, 1/4 of the whole object, right? Now, what if instead I wanted to do 2 divided by 4? How could I think about that? Well, I could think about it as 2/4 of an object. So I have this object again, I divided it up into fourths, and now I want 2/4. So now I'm going to grab this much of the object, and so this is going to be half of a whole object, right? So that's another way we could think about division here. I can actually think about 2 divided by 4 a different way. So let's try this 2 divided by 4. Now I'm going to see this 2, I'm going to see this as 2 whole objects. So I'm going to grab 2 whole objects like this. I've got 2 whole objects now, and then I'm going to cut those 2 objects into 4 pieces. So let's cut this into 4 pieces, and then I'm going to wind up with one of those pieces. Once again, this is half of a whole object. So there's a few different ways to interpret division as cutting up an object. This can make a lot of sense visually, graphically, but it kind of only takes you so far, especially when you start talking about like dividing negative numbers. Like, what does that mean? It's better for us to find a more abstract way of thinking about division. So that's what we're going to do next. We want to think about division as the inverse operation of multiplication, just like we saw subtraction as the inverse operation of addition. What does this mean? Well, let's say we start with some number a, and we multiply it by 3 to get b. So that's multiplication. Now, if we wanted to do the inverse, maybe we start with b and we want to get a. How do we get a? Well, we're going to have to divide this quantity b by 3. So dividing by 3 sort of undoes the multiplication by 3. That's the idea here, right? So dividing by 3 here undoes multiplying by 3. Let's look at another example of this. What if we start with 4 multiplied by 3? Well, that's going to give us 12. So now if we start with 12 and we want to get 4 back, we want to undo this multiplication, we're going to have to do 12 divided by 3. Okay, so multiplication and division are inverse operations of each other. Division will undo multiplication, multiplication will undo division. So that's a good way of thinking about it, but I think there's a better way to think about division. I want to think about division as a fraction constructor. Okay, it sounds a little bit strange, but go along with me here. Let's actually just look at the division symbol first. Okay, so here's the division symbol. And to my eye, this symbol actually looks a lot like a fraction, doesn't it, right? So you can sort of imagine here that this dot is the numerator, this dot is the denominator, and here's the little bar that you'd use to build a fraction, right? So this symbol literally looks like a fraction, and we can use it as a fraction constructor. Let's start with an example here. How about 24 divided by 4? Okay, so what's going on here? Well, we can imagine taking this 24 and bringing it up here to that numerator, and taking this 4 and putting it down here where that dot is on the bottom. And what do we get? Well, we're going to get 24 divided by 4. We've constructed a fraction. And of course, this is going to equal 6. But that's the idea. This division operation we can imagine is just building a fraction, right? Here's another example. How about 4 divided by 8? What does that equal to? Well, it's equal to 4 over 8. And that would also be equal to 1/2. Okay, so there we go. We can treat division as a fraction constructor. Here's sort of the general rule. We can say any a divided by b is the same as a over b as a fraction. So that works. That's kind of cute, but I think there's an even better way to think about division. So this is actually my favorite way of thinking about division, and that's to imagine it as actually multiplication. So there is no division. Division doesn't exist. All we have is multiplication of a reciprocal. Okay, so let's look at an example here. We looked at 24 divided by 6, and we saw we could think of this as a fraction. We could think of this as 24 over 6, right? But there's sort of like a middle step here that we're missing. And to get that step, I want to think of this as actually 24 multiplied by the reciprocal of 6. And that is actually what gets us to the fraction of 24 over 6. Okay, so we're taking this division operation and thinking of it as a multiplication of a reciprocal. Okay, now this is a very powerful way of thinking of division. We're going to see why in just a second. Let's do another example first. Let's think of, let's say, 3 divided by 5. What is this really doing? Well, it's 3 multiplied by the reciprocal of 5, and that would give us 3 over 5, just like that. Okay, so as a general rule, we could say any a divided by b is really the same as a multiplied by the reciprocal of b. This changes all division into multiplication. Let's see why this is so powerful. Let's do a comparison between multiplication and division. We're going to focus on the commutative and associative properties. When we looked at multiplication, we said it was commutative. That meant the order of this operation should not matter. If I swap the 6 and 4, I should get the same answer. Okay, let's test that out. 4 times 6, well, that's 24. 6 times 4, that's 24. Well, that's the same number. Okay, multiplication is commutative. Let's test the associative property. That was telling us that the grouping here shouldn't matter. I could group the operations, do 2 times 4 first or 4 times 6 first. I should get the same answer. Let's test it out. 2 times 4 is 8. 8 times 6, well, that's going to give us 48. 4 times 6 is 24. 2 times 24 should give us 48, and that is the same. Okay, so very good. Multiplication is associative. Now let's test division, okay? If we swap these two numbers around, do we get the same result? That is the question ahead of us. Well, let's test it. So 4 divided by 6, I'm going to write this as 2/3. 6 divided by 4, well, that's 3/2. Are these the same number? No, they're not. 2/3 and 3/2 are not the same number. Division is not commutative. Let's test the associative property now. Okay, so 2 divided by 4, well, that's the same as 1/2. If I want to divide that by 6, well, that's going to give me 1/12, isn't it? Okay, over here, 4 divided by 6, that's the same as 2/3. And 2 divided by 2/3, it turns out this is going to be 3. 1/12 is not the same as 3. Division is not associative. This turns out to be a problem. How can we rescue ourselves from this problem? We're going to treat division as actually multiplication. We're going to treat it as the multiplication of a reciprocal. Okay, so let's see if we can now rewrite these expressions using this new interpretation of division. I'm going to say, instead of 4 divided by 6, I'll say 4 multiplied by the reciprocal of 6. And now I'll swap those around. And let's see if we get the same number. Well, okay, 4 times 1/6, that's the same as 2/3. 1/6 times 4, that's the same as 2/3. Well, that's the same number, okay? This is now commutative. Let's see if we can do it now for the associative property. So 2, instead of divided by a 4, I'm going to say it's multiplied by the reciprocal of a fourth. Instead of divided by a 6, I'm going to say multiplied by the reciprocal of 1/6. Okay, so this is what we've got here. And let's bring it onto this side. Okay, so we're going to test 2 different types of groupings. We're going to see if this is now associative. Okay, so for this first one, we've got 2 times 1/4. That's the same as 1/2. And 1/2 multiplied by 1/6, well, that's the same as 1/12. Okay, on the right-hand side, 1/4 times 1/6, that's the same as 1/24. And now we're multiplying 2 times that. Well, that's going to give us 1/12. 1/12 is the same as 1/12. Congratulations. Now everything is associative. So we have rescued these properties by treating division as actually multiplication in disguise. It's the multiplication of a reciprocal. Okay, so hopefully this was a good review of multiplication and division. We looked at the concept of a multiplicative identity, the number 1. Any number times 1 is that same number again. We also looked at the concept of a reciprocal, which is like 1 over a number or like flipping over a fraction. And we looked at division in a few interesting ways. For example, as a fraction constructor, or the most powerful way as actually multiplication in disguise, multiplication of a reciprocal. And that's kind of the most powerful way to think of division, because then we can recover the commutative and associative properties because everything's multiplication. And that will allow us to solve and manipulate algebraic expressions a lot more easily.